Hello everyone. So today we have an interesting problem from GATE 2016, and the problem is from calculus section. The problem says that we have to determine the value of root over of n square plus n minus square root of n square plus 1 as n approaches infinity. So we have to determine the limit. So let's start with the problem. So in the first step we will just try to rationalize the numerator and denominator by multiplying it with the same factor. So let's proceed. Here we will write limits n tends to infinity and n square plus n minus root over of n square plus 1, and we will just multiply it with the rationalizing factor, that is root over of n square plus n plus root over of n square plus 1. In the denominator we will also have to do the same thing, root over of n square plus n plus root over of n square plus 1. So in further simplification we will get limit n approaches infinity. In the numerator we will get n square plus n minus n square plus 1, and in the denominator we will get the same thing, root over of n square plus n, and now it is plus root over of n square plus 1. Further proceeding we will get limit n approaches infinity. This n square and n square will get cancelled, and we will get n minus 1 in the numerator, and in the denominator root over of n square plus n plus root over of n square plus 1. So now here if we just proceed, we will get this is equals to limit n approaches infinity, and if we just divide the numerator and denominator by n, we will get this root over of n square plus n whole divided by n plus root over of n square plus 1 whole divided by n. Now in the numerator portion we can just distribute the n in the denominator, that is 1 minus of 1 by n, and in the denominator we will get root over of n square plus 1 by n square by just inserting the n within the square root sign. So n square plus 1 by n square. Further proceeding we will get limit n tends to infinity 1 minus 1 by n, and in the denominator root over of 1, this will be n square plus n, and this will be n square plus n, 1 plus 1 over n, and in the next part root over of 1 plus 1 by n square. Now if we just further simplify this, we will get equals to limit n tends to infinity, this will be 1 minus 1 by n by root over of 1 plus 1 by n plus root over of 1 plus 1 by n, this thing whole square. Now further proceeding we will get this thing as limit as n tends to infinity. We can say that 1 by n tends to what? 1 by n will tend to 0. So we can write that 1 by n tends to 0 instead of n tends to infinity, and in the numerator we will get 1 minus 1 by n over 1 plus 1 by n plus root over of 1 plus 1 by n square. Now these 1 by n portions, this part and this part, they will get cancelled out because they are all 0 according to our limit definition. So plug in this limit into the function, we will get 1 minus 0 by root over of 1 plus 0 plus root over of 1 plus 0 square. On simplifying we will get 1 over root over of 1 plus root over of 1. This gives us 1 by 1 plus 1, which is 1 by 2, and in the final answer we will have to write 0.5. So we have got our solution, which is 0.5. You can see the problem. So we have got our solution. So hope you have enjoyed the video very much. If any doubt you can write in the comment section, and please give a like to my video and share it with your friends to spread the knowledge of mathematics among all. Thank you. Ending my video here for the day.